Okay, we're going to start today and we're going to talk about some basic terms we're going to use all the way through geometry and some postulates that we accept to be true in geometry. There is a notes sheet that if you want to fill in as you listen and watch this video, you can. If you want to just write down what you think is important, you can, or you can look at the filled in copy of the notes that I will post. The first thing we're going to talk about is a point. This is point A right here. Okay, and the notation that we use for points is we write the word point and then the letter, so point A. That's how we know that that is point A. And a point has no dimension, and we always just have a dot on a diagram when we're representing a point. The next important thing is a line. A line has one dimension. It's represented by a line with two arrows or arrowheads on the end. And it extends without end. So we assume that it just keeps going off as far as it can in both directions, forever and ever. But through any 2 points, there's exactly one line. So we can always name a line with the 2 points or any 2 points that are on the line. Then we have this little lowercase l here. Sometimes when this is not associated with a point and it's at the end of a line, we can just call it line L with that lowercase l. We can also name this line AB with the words line AB, or we can name it line AB with the notation over the top, the line notation. So it just looks like a line with 2 arrows on the ends. Or we can call it line BA or line BA this way. A plane has 2 dimensions. It's represented by a shape that looks like a floor or wall, but it extends without end. So this is a plane over here. There's a lot of different ways we can name this plane, but when you're visualizing a plane, think of a piece of paper, okay? So we could draw lines all over that piece of paper and we can put points on it, but it's still flat, okay? It only has 2 dimensions. It's 2-dimensional. Nothing can come out of that. You can't really draw a line up out of the paper, okay? So through any 3 points that are not on the same line, there's exactly one plane, which that means that these 3 points that are not in a line, so that's really important. 3 points that are not in a line can name the plane. Okay, so this one can be called plane ABC, or it could be plane CAB or BAC or any combination of those 3 letters. It could also be plane M, because this M is not associated with a point. If it was associated with a point, then we would need 3. Okay, so this is line AB, and we're going to use this to talk about some segments and some rays. Okay, a line segment, it has endpoints. So the difference between a line segment here and the line up here is that there's no arrows here. This has 2 endpoints, A and B. So this is segment AB. And you can write that using the notation like right here that has a little line over the top, and it's AB. All the points in between A and B are on that line. And we can also call this line segment BA. The order does not matter because they're both endpoints. Where the order matters is when you're talking about a ray, because a ray has one endpoint and one side that continues on forever. Okay, this one would be ray AB, because when we name a ray, we always start with the endpoint. That should be the first letter. So this is ray AB. This one down here, however, is ray BA, because B is the endpoint. Okay, so these AB and BA, these 2 pictures are different, which means they have different names over here. Okay, and then we have opposite rays. Opposite rays are 2 rays that have the same endpoint and extend in opposite directions. Okay, so for example, on this one here, this one down here is ray CA would be 1, and ray CB would be the other one. And so ray CA and ray CB are opposite rays. So collinear points are points are on the same line. So on this first diagram here, A, B, and C are all collinear points. So A, B, and C are collinear. Okay, on this diagram over here, the second diagram, we have a plane, we have two different lines through it, and we have point V. Okay, so collinear points are points that are on the same line. So points S, P, and T would be collinear. Points Q and P would be collinear because they're both shown to be on the same line. Okay, but points V and T could also be collinear, as well as B and S, and really any 2 points, because any 2 points create a line, and there's a line that goes through any 2 points, and that's important to remember. You can always draw a line through any 2 specific points. We couldn't, however, have line MN, because M and N are not points, they're labels for those lines. So now we're going to look down here and we're going to see if line AB and C are collinear. So we have line AB here, and it's the line that goes through A and B, and then we have point C. And we see that point C lies on line AB. So yes, AB, line AB, and C are collinear. Now we have B and F. B is a point and F is a point. And through any 2 points, there's exactly 1 line. So yes, these are also collinear. Coplanar points are points that are on the same plane. So for example, these bold points here, A, B, and C, which are the vertices of this hexahedron or cube, those are all coplanar, because the way I like to visualize it is I could take a piece of paper and I could slide it through A, B, and C at the same time. But then if you look at this next diagram over here, this next hexahedron or cube, E, B, and C are also collinear points, because even though it would be diagonally through the cube, E, B, and C would have a piece of paper that I could slide through them. So now we're going to look at this diagram and answer these questions. So A, B, E, and C. Are they coplanar? And the answer is yes. Because A, B, and C are on the same line, and E is over here, and that line intersects at point B, so we know that they are coplanar. A, B, and F. They are also coplanar because any 3 points that are not collinear are coplanar. And then we have line EB and A. That is also coplanar because, again, you can think of visualizing a piece of paper that you could slide through line EB and point A. So if you look at this question on the bottom, take a minute to read it and think. Pause if you need to. What do you think non-collinear and non-coplanar mean? Well, they probably mean exactly what you think they would mean. Non-collinear means there is not a line that goes through it, and non-coplanar means there is not a plane, that the points or the lines do not lie on the same plane. Okay, so an intersection is what we would think of as where 2 things cross. It's what they have in common. Okay, so the intersection of these 2 lines is point A. Okay, so it's the point that they have in common. So when 2 lines intersect, so 2 lines make a point as an intersection. So that would be the intersection point. Okay, and the intersection of 2 planes, so 2 planes cross, and that creates a line. So the intersection of these 2 planes would be line Q, because that is the line that they share in common. Okay, so the intersection is what they have in common, or where they cross each other. You heard me say before, a cube or a hexahedron. They are the same thing. They mean the same thing, but we'll use it a lot, a cube, to talk about lines and planes and points and intersections. And so it's good to understand what a cube or a hexahedron is. So this cube, it has 12 lines or 12 edges. So that would be along the edges right here. Let's see if I can draw on there. There we go. So there's That would be the 12 lines, or those, the corners would be right here where you have the lines intersecting. And then the faces would be what we think of as a plane. So like I'm going to color in the front side of this face just so you can see that that would be what we consider the face. And there's 6 of those. So pause the video now and look at the page if you have it in front of you, if you were able to print it, or just answer the questions based on the vocab sheet and the hexahedron that is pictured on the sheet, and try and answer those questions. And once you've answered them, come back and watch the rest of the video. Okay, if you're back, I'm going to go through and kind of answer these questions based on the pictures, and you may have different answers, but I'm going to go through what some answers could possibly be for all of the questions. So if you look at this cube and you think that ABC is on the top, the plane that would be on the bottom would be plane EFG, or you could call it FEG or HFG, as long as you're using 3 points that are on that plane. So that brings me to the next question. 3 different names for the plane would be, this could be one, EFG, FGH, you could name it HGF, really any combination of those 4 letters, and we only need 3 of them to name the plane. The intersection of plane BCGF, so that's this plane on the side here, and plane GHDC, so the one on the back, would be the line GC. And you would want to write it correctly with the notation, or write the word line in front. There's a lot of possibilities for non-collinear points. So I'm going to pick 3 non-collinear points, and I'm just going to pick on the front here, and I'm going to say A, E, and F. Points A, E, and F, and they lie in plane A, E, F, because they are 3 non-collinear points, so that's how we can name that plane. So you could really pick any 3 points and call the plane that, as long as they are not collinear. The intersection of plane HC or HGC and AED, so that's this back side here, and HCG is on the back, would be the line HD or DH. Either way. All right. The plane that contains E, H, and C, so E, H, and C, it's the one that goes kind of diagonally through the cube. Okay. Another point that is coplanar with A, H, and E would be D. Another point that is coplanar with A, D, and G would be F, because again, that's that diagonal plane. 2 lines that contain point B, really you could pick any other point on this hexahedron and put it with point B, so we could call it BH, we could call it BA, anything that has a B in it. And it doesn't matter if the B is first or second, because we're talking about a line, not a ray. And then, where do DC and FB intersect? And the answer is they don't. They are what we call skew. That's an important word to remember, that those 2 lines are skew. So they are not parallel, but they will never intersect. And lines GH, or HG and DH, they intersect at point H. Okay, I only have 10 seconds. Here's the last slide of answers. Look over them and let me know if you have questions. I'm sorry that I don't have time.